For 100 years, our entire understanding of the universe has been built on the ideas of one person, Albert Einstein. His theories of relativity gave us the rule book for space, time, and gravity, painting a very specific picture of how everything began. But theories are one thing. What happens when you build the most powerful time machine in history to go and see for yourself? What happens when you push those rules to the absolute edge, to the very beginning of time? We've all heard the story. The universe started with a big bang, a blinding flash of light. But what if the biggest surprise from the James Webb Telescope wasn't some flashy new discovery, but a confirmation of something we thought we already knew? What if by staring into the supposed darkness at the dawn of time, Webb found the most stunning proof yet that Einstein had it right all along? To really get what the Webb telescope found, we need to rewind the clock, not billions of years, but just over 100, to a time when Albert Einstein completely changed our picture of reality. His theory of general relativity told us that space isn't just an empty stage for things to happen on. It's a dynamic, active thing. It can bend, it can ripple, and crucially, it can expand. That single idea led to the cornerstone of modern cosmology, the Big Bang. The idea that 13.8 billion years ago, our entire universe was squeezed into a single, scorching hot point. From that moment, space itself started expanding like a stretching canvas, carrying the seeds of today's galaxies along for the ride. Using this blueprint, scientists mapped out a cosmic timeline. They predicted that after the initial fireworks, the universe would have cooled and gone dark. For hundreds of millions of years, a period called the Cosmic Dark Ages, there were no stars, just a thick, soupy fog of hydrogen gas filling every corner of space. The prediction was simple. The first stars and galaxies would have to form slowly and painstakingly. They'd be small, faint, and lonely, fighting to burn through that cosmic fog. According to our models, the early universe should have been a pretty quiet, almost empty place. That was the story we expected to find. And then we opened Webb's eyes. This is where the James Webb Space Telescope comes in. It's not just a bigger Hubble, it's the most powerful time machine we've ever built. Webb was designed to see the universe in infrared light, which is key. Why? Because as the universe expands, light from the oldest, most distant objects gets stretched out, shifting from visible light down into the infrared spectrum. Webb can see that stretched out light, allowing it to look back over 13.5 billion years to just a cosmic hair's breadth away from the Big Bang.
Its mission was one of the boldest in science history. Stare into that primordial darkness and watch the cosmic dawn as it happened. Would it find the faint, scattered galaxies our theories predicted? Or was the universe hiding a surprise in its baby photos? The pressure was on. Finding what we expected would be great, but finding something different? That could mean a century of cosmic understanding was built on a shaky foundation. When the first images from Webb came back, astronomers were absolutely floored. Where we expected a quiet, sparse cosmic nursery, Webb showed us a bustling, brilliant metropolis of galaxies. It was a total shock. The telescope was finding way too many galaxies, way too early. And these weren't the small, dim prototypes we were looking for. Many of them were shockingly bright, massive, and looked surprisingly mature for their age. A perfect example is a galaxy called Jade's GS Z14-0. Webb saw this galaxy as it was just 290 million years after the Big Bang, making it one of the oldest we've ever confirmed. But it was bafflingly bright, powered not by a black hole, but by an absolute frenzy of starbirth. As one researcher put it, it is stunning that the universe can make such a galaxy in only 300 million years. This threw a huge wrench in the works. Our standard model of cosmology, the one built on Einstein's work, said there just shouldn't have been enough stuff in the early universe for these universe breakers to form so big, so fast. For a minute there, it felt like everything we knew might be wrong. The alarm bells were ringing. Was it possible Einstein's theory had a fatal flaw? But the mystery didn't end there. There was another, maybe even weirder problem. How were we seeing these galaxies so clearly in the first place? Remember that thick fog of neutral hydrogen that was supposed to fill the early universe? That fog should have blocked the light from these young stars, making them totally invisible. The period when the first stars and galaxies had to burn away this fog is called the era of reionization. Our models told us this should have been a very slow, gradual process. But Webb was seeing light that should have been smothered by the fog. This meant these early galaxies were clearing out massive, transparent bubbles in the fog around them far more efficiently than our theories allowed. It was like the universe had a cosmic leaf blower, and it was working way ahead of schedule. The evidence suggested our timeline for when the universe became transparent was off. Scientists started talking about a photon budget crisis. The galaxies Webb found were producing way more fog-clearing light particles than our models could explain. It seemed like our whole understanding of the universe's first billion years was missing a major piece of the puzzle. Just as headlines started asking if the Big Bang was broken, scientists did what they do best. They got back to the drawing board. They didn't scrap general relativity. Instead, they took a hard look at their own assumptions and the computer simulations built on Einstein's framework. And that's where they found the answer. The problem wasn't Einstein's theory. It was our models. The old simulations had underestimated how much more clumpy the early universe was. They hadn't fully accounted for the fact that some galaxies would form in incredibly dense, rare pockets of matter where star formation could happen with unbelievable speed and intensity. Once astronomers tweaked their simulations to account for these hyper-productive environments, everything started to click. Suddenly, these impossibly bright and massive early galaxies weren't impossible anymore. They were just the exceptions that proved the rule, born in the most extreme cosmic nurseries imaginable.